Thank you very much for inviting me for this event. I would like to thank Savosec and also Kuosec, who is organizing this event. And I am welcoming you all to this session. And also I am welcoming to you all to this Savonia University of Applied Science. Thank you so much. So should I continue or? Yeah, okay. Yeah, so, okay, so I think I'm going to discuss today this topic. My name is Rajeev Kanth. I'm a principal lecturer at Savonia University of Applied Sciences. I'm also doing as a docentship at University of Turku. So this is my short introduction. I did my Doctor of Science from University of Turku, Finland in 2013. I did also this postdoctoral research position at KTH, Stockholm in 2014 and 2015. In 2019, I have a docentship in data science, and I got the docentship in data science from University of Turku. I have been working at Savonia as a principal lecturer since last 7 years, and I'm also managing a couple of projects. And today, which I'm going to give a talk, which is AIQUSEC project, which is Business Finland funded project. And we will walk through some of these cybersecurity solutions for critical infrastructures. So for me, I would like to say a couple of more things. I'm teaching several courses at Savonia. I'm teaching like artificial intelligence course at Savonia. We like IoT, Internet of Things, sensor technology, environmental measurement, data analysis, and so on. I have quite a long time, 25 years of teaching and research experience, and I have given so many talks all across the globe. If you are interested, my web page is here, so we can. So today's agenda. So today's agenda, actually, I will going to talk more on two entities. And those two entities are, we have this side, Kuopio Water Cluster. We also call it Savonia Water Lab. And another entity that we have is Savonia Smart Factory. So around that, we are doing lots of use cases. Around that, we are playing lots of experimentations on like different cybersecurity stuff, actually. So I will be going to explain in today's talk some of the proof of concepts that we have built for this Business Finland AIQUSEC project and also for Savonia Smart Factory. So as I mentioned, this AIQUSEC BF Business Finland project, I will talk a little bit more about that. And one of the key technologies that we need to understand, which is in European level, it's a very popular, getting popular when we talk about security. And that is, we call it OPC-UA. OPC-UA stands for this Open Platform Communication Unified Architecture. So how we could securely transmit the data from one vendor to another vendor. How we could add certain layer of abstractions. What is the best protocol that we could use, for example? And OPC-UA is one of that protocol that I'm going to talk today. Some of the use cases, proof of concepts, and some innovations. I will, in my talk today, you will be seeing some of those small video clip as a demonstrators, actually, what we have done also. Of course, when we say like a smart factory or the critical infrastructure, there is probably, you might have heard the word like digital twin. So digital twin, I will talk a little bit about digital twin. You would have little bit knowledge how this digital twin works actually, how digital twin could be utilized to enhance the efficiency, productivity, and so on of any infrastructures such that. Of course, this AI is booming day by day. As we know, like artificial intelligence has been utilized in many things. And of course, this in AIQUSEC project, we have small work packages where we do some of the research on artificial intelligence. And then in this project also we have created, I would say, two things are very important. One is how we would transfer the data, and there is terms, we call it post-quantum cryptography. And second one, we call it quantum safe. So this is, we have this Savonia Jyväskylä University, because Jyväskylä University is also part of that. So we will talk about this one. So, and then little bit I talk, if I have time, I have some like robotics related research, I will go through that. So the first of all, what this Kuopio water cluster is. So Kuopio water cluster, it's a network of universities, companies, for example, research institutions. Like our goal is to like advancing this clean water solutions. What are the, and how we could use technologies for particularly. So this network concentrates water sector research, development, and innovation, particularly in this Pohjois-Savo region particularly. And we have been cooperating with many nearby Savo region companies where we do lots of tests. We do lots of cooperations with the companies and testing and commercialization services. So head of the research, this water cluster is Eero Antikainen, you can see, and we have this picture where you can see that like Savonia, Savonia GTK, then we have Finnish Institute of Healthcare, and then University of Eastern Finland, and Luke. So we have this network actually. Now let's talk on little bit on this, what we have this Business Finland project actually. So this Business Finland project is, we call it AIQUSEC. AIQUSEC, probably you might have think that what's the main, acronym for AIQUSEC. So AIQUSEC is simply like artificial intelligence, quantum safe security. So something like that. And then we have this approximately 2 years funding, which is funded by Business Finland. This project is going to end actually in 2026, February. We have some companies like Savonia, Jyväskylä University, Nokia. Nokia is working with us, SSH and Process, and also F-Secure. There are a couple of 2 more companies, but they are not active right now actually. But these companies are actively, we are cooperating, and I'm going to show you some of the results that we have done along with those companies actually. Nokia, actually SSH and Process. So if you see this slide, who are involved with this AIQUSEC project? So we have a couple of persons here. I think some persons are already here. I can see here, like Eero Antikainen, he is the head of the research for this Kuopio water cluster. And then we have Patrick, which actually, so he was ex-project manager. I am the PI for this from the beginning, and also now I am working as a current project manager. Aki Haponen, he is the development manager at Savonia. We are cooperating so many things with this, and Aki is also supporting us in this AIQUSEC project. Kuntal Ghosh, I can see here, so he is the RDI expert. Mikko Auriola, I don't know if Mikko is here or not. So he is a test engineer, and he is responsible for lots of database management. Because when we say security, when we say AI, then first thing is data. So we are talking more on data, we are collecting data, and he is responsible for those all database management. We have also project assistant here somewhere actually, so MD Khan, and we have also project assistants Finlay Hare. So he has been contributing to this project. So now, we have short video, you can see it here, and this video will tell you like what we are doing particularly in the smart water actually. So this, when you see this smart water, this is our look, if you see that side, and we have approximately 2 kilometers of water pipeline, 4 loops, several sensors, I would say like 70 sensors we have, and we are getting the data actually. And from those data, we try to see that how we could make the data network more secure particularly. So I will give you, I think it's 1 or so minutes, so let's have a look. Yeah, so you can see this is our it has actually, when we say OPC-UA architecture, it has server and client architecture, and there are so many clients that we could use. One of the client is like UA expert. These are some of the data that are like hidden now here, but this contains some of the IP addresses, so they are like little bit blurred here. Similarly, there are some others like process, for example, or OPC-UA, for example, and also, so these data which you see here, these are our real data from the sensors, and we used process OPC-UA. So process is one of the company. So from that we could use, and we integrate this with, similarly, there is like another historian. Nowadays, this historian, this video is a little bit older video, but we are now, this historian is no more now. So, but then we have self-made and a client with a Node-RED. So you can take a look. So these all data are like real-time data, which we have several sensors like temperature, flow meters, like other sensors data, pressure value data, valve pressure, and so on. So all of those data can be visualized in the system. And for example, if you have, and we are utilizing those data, for example, to know that when this system gets failed, or what could be the predictive maintenance, and so on. So, okay, I think this is almost the end of this, so I will go. So this, I think we have this. So now let's talk a little bit of the architecture, what we have in our system actually here. So as you see, we have a back-off system, and then the server side, we have this Savonia network. There are two ways that we could use, either Toshibox, or we can use this TwinCat OPC and send to the cloud, send to the client side actually. So there are, and this is, which you see here, this is the like architecture of this, where we have different loops of this water cluster lab, and where we do lots of experimentation. So this is, I think we saw already, this is the live data from different sensors, and which are visualized using process OPC-UA. So what does that mean in practice is that if you use OPC-UA, your data is somehow secured than normal encryption method. Because we have some encryption method, but that data is more encrypted actually. So now let's talk a little bit about this digital ignition HMI digital model, which we have here. So if you see, yeah, so you can see we have created a small proof of concepts with lower number of sensors like flow meter, temperature, and pressure meter, and this could be integrated with our real system, and then it is built with this ignition HMI, for example, and you have the control over this digital twin. This is a very small proof of concept, but you can control, for example, this on and off remote, which you see here, we can control the entire system from the simulation, for example. Now, I think this is the another view. For example, you see here, we call it Unity OPC-UA, and this is ongoing work, and we have lots of cooperation with different company, and this one which we have is with 3D Talo. 3D Talo, I don't know if someone is from 3D Talo here, but we are cooperating a lot. So the idea here is, how do we know in real time the pressure of these? We have, as I mentioned, these are 4 loops. So this is 1, 2, 3, 4. So all 4 loops are here, and all of these values can be seen, all of those values can be seen real time with this. Maybe you can see this with the Unity. So this is we have created, it is created with the cooperation of 3D Talo, and now it's an ongoing work now. We have been working, and it's possible to see from the virtual reality. So if you have the gloss, you can see this with the virtual reality, and it shows like this. So we are now, it's in ongoing work actually. Now I think we have some of the results that I would like to share with you here. This is one of the data. If you go to our water lab, we have this kind of data, and this is built by one of our project assistants, also our student from Savonia. We worked on different models, and then these values which you see here, these are the real-time value, like what is the time level, what is the residual chlorine, what is the pressure, and so on. So all these things can be seen from this real-time data management. Also, we have been working with, for example, this prediction error. For example, this is LSTM prediction error, one AI model that has been done. We call it, we have some earlier project like VTT data actually, and VTT execution time, so we can see this. So now I will talk a little bit about, so this was what I discussed. They are all towards this smart water lab. Now we switched our gear to talk a little bit about a smart factory. So this is a smart factory, and we have done some work already here. So you can see this is the client computer here, process OPC-UA monitor, process OPC-UA 4, this is the new version, and I think we are utilizing this very heavily to make our system more robust. Also, we use earlier this visual components and UA experts and so on. So in the smart factory side, we have like one master PLC and 8 slave PLCs, and they are connected with 2 networks. The master PLC and slave PLC are connected with the Profinet, and also this our ERP lab. And with all of these, for example, all of these slave PLCs are connected with this constant application protocol. So, for example, if you want to give some product value to the ERP system, so this will go from here to this one, and it processes, goes to master PLC, and it starts working actually. There is one picture, so you can see it here. So this is our Savonia Smart Factory, which is connected with TIA portal, and then which is from the client and server side. This in between, there is a OPC-UA Foundation. And I would like to tell you also this OPC-UA Foundation, Savonia is also a member of that. And this side, we have created this 3D model. So this is a picture of this, which you saw earlier. These are like four slave PLCs, 1, 2, 3, 4 slave PLCs, and in the top side you will find one master. So this work is being done, and it has like this kind of products which we have in our demo area. Maybe later when you have time you can see that. And then we do lots of experimentation. For example, how do we enhance the productivity? How we enhance the productivity? What is the timing between production from one product to another product? How we could make it more, for example. So these kind of things. So this is one of the small video. You can look at it now. So this is the same replica with this same one, and here you can see this how this node feeder white and node feeder black. There are this white one and this is black one. So this and real value data is coming there. So you would have knowledge like how to increase the efficiency. What are the human being? How human being could be utilized in a factory environment? How you could optimize that? So if these informations you don't have actually, if you don't have this digital kind of a replica, for example. I hope you got this, for example. So you can see here, like human being Anna is here. So how far, how much distance she is traveling actually in the whole timing. In one parameter, how we could do if we change some parameters, if increase the efficiency, for example. So these kind of things we have been doing. So like how your machine has been utilized, total travel distance by the human being, or total travel distance by some other persons, for example. So let's have a look. I think it's a couple of, I think 1 minute more. So the utilization and then count parts, how many count parts are being done already, red, black, and others. So this is, you can see it very, and this is our like software-based virtual machine we have connected, and it's working fine actually. So I think I will go a little bit further. I don't know if I have time. Yes, I think I have time now. So. So now I think I will talk a little bit about this overall AIQUSEC plan architecture, which is one of the biggest goal of Business Finland, so that how we could transfer more securely from Savonia factory data to Jyväskylä. There is one person who came from Jyväskylä also, and he will be going to talk more on that. So the main question is, our role here is, in Savonia side, we are creating the data collection, and we send those data to Jyväskylä University. But because Jyväskylä University is very good at AI things, they are very good at cybersecurity, so they are now analyzing those data, for example. But the question is how we could securely transmit the data. So this is one question. So here, if you see here, we have a process. This is our factory side here data. So in our factory data, we have connected this process and this privileged access management software, which is given by SSH, which is the company, and creating this tunneling. And this is the Jyväskylä side. And we tested it. It's worked quite fine. We have tested it, and it worked with one of the videos. So this is the architecture. You can see here, like this is the smart factory, operational data. Of course, we can send not only operational data, because when we talk about a smart factory, we have two kinds of data. One is IT data, information technology data, and another one is operational data. So operational data means that how many, what is the status of the station, for example. If the station is filled or not, for example. So this kind of OT data, it sends to the this process forge, and then finally this prefix extender, and this is the tunneling which you see here. This is the tunneling. So, and then it goes to the prefix server of this process in the Jyväskylä side. So now you can see the entire thing what I said in this video. So this is the architecture here, what we mentioned earlier. So the main target is this quantum safe and PQC. So this is the factory which I showed you earlier. This is the factory which we have, and now this is these are the like products which we have actually. So this is the product, like white base, black top, and then bolt, for example, and then it comes red bolt, and then it comes there. And here actually this is the defect checking actually. Some of our students now doing the product which is coming, is this right or not? So with the image processing or the image detection, it's possible to do that as well. So now it's come to this transmission and tunneling, for example. So we have this 7S500 master PLC has integrated with OPC-UA server, and which is the host machine. From the host machine, sending data to the guest or the, for example, the another side, destination side. So, and I think there are some more information here, how it has been done. So this is the PQC tunneling from Jyväskylä to Savonia, and I think we have connected it very nicely. We could not show you like all the data actually now here, but I think it has been tested very well. Okay, so this is the Uvascula side where the data is going, and they are doing more AI-related work there on that. So now I move to a little bit talk on AI-related research, which we have been doing. Of course, these results are not robust now, I would say. We are ongoing research nowadays, actually, but we have a project until February 2026. But we are trying to get very robust results out of the data which we have. So if you see, this is our AIQUSEC lab water data sets. This is like a very huge data, 648K by 73. So 73 means that it has the number of columns or the features of the data sets. For example, we can say this, if you can see there, this is the timestamp data. So every timestamp you have the data here, and each like sensor value like L4, P3, pressure, temperature, and so on. Now, the idea here is we have run our AI model, and the AI model is this LSTM, which is a very common model, LSTM with a variational autoencoder. We are working now, I think Kuntal is working on this, now working. So these 20 sensors, we got very good results with accuracy of 0.99, and like if you see this F1 score, these are accuracy, precision, recall, F1 scores are the matrices, so that this will evaluate how your model is particularly. So we get it very good results so far with the 20 sensors, but still we are working on this whole entire set and see that there are so many, because if we talk about AI is growing quite fastly. So this means that lots of algorithms are coming up, and we are trying to use which algorithm fits to our model. For example, there are so many like SAP-based or attention-based. So we have for example, like where is the valve manipulation or the flow spoofing or the overheating or cooling disruptions. So among several sensors, the model would automatically should tell that, hey, this is needed where you have to need like likely affected sensors, which are those likely affected sensors, and so on, based on this value. Similarly, we have this F1 drop is another method of like interpreting. So if you have this delta F1 score mean value, like it is decreasing, for example. So which sensors are very highest critical, which is high, which is moderate, and which is nothing negligible. You don't need to worry about those sensors. And this is really very important to understand in the critical infrastructures nowadays in real time. People don't know, and maybe some big disasters may happen. Okay, so this is about some of my talks on this. I have 2 minutes time now. So this is SLAM and autonomous navigation that we have worked with. We have working a little bit other research areas like robotics and so on. So I would like to show you this one. So this is the video is not that good, but we have filmed this video here, and we have this basically, we call it Bob, this unitary Bob robot, which we have, and we trained this robot to avoid with the SLAM method, actually. So this has worked quite fastly and nicely, actually. It has been working. It gives you the perfect localization where it is and what is the surrounding behind it, and so on. So lastly, this is one of the very small work that our students did with our Nero robots to sorting, and how we could train the robot such that it would detect the objects for sorting. For example, if you see there are wing nuts and the bolts, for example. So this robot has been trained to recognize only wing nuts and then process it here. So I think this is the last slide probably. We have been working here at Kuopio. We have lots of companies nearby, particularly some of them I have written here. Maybe all of them we don't have cooperations, but we have been cooperating with many, like our students goes to Finivector, from Honeywell, we have so many, staff from Honeywell also. I think in IoT, we have 2 staff from Honeywell. We have cooperating like in IT sector, all of those. So this is all my presentation, and thank you very much. If you have any questions, I would love to, love to answer this. But of course, we don't have so much time. But of course, I'm here for a while. If you have any questions, you can ask me. Thank you so much.
What mic I'm speaking? Maybe I'll borrow your mic. There's time for one question. Ja koska olemme Suomessa, innokkain kysyjä saa ilmaisen ämpärin.
Yeah, if you have any questions on my talk, it would be, maybe I would love to answer your questions if you have any. From the top, maybe. Okay, yeah. So Kuntal is my, he is working with our team. Yes, please, Kuntal.
Yeah. Yes. It was
Whole bucket.
okay.
This is the Finnish tradition.
So regarding the threat profiling, we are using the SHAP analysis. Apart from that, any other method are available?
I think there must be. I think you know more probably, but we are working on that. Of course, there are like the threat. The next task which you are doing now is threat profiling and classification.
Yes.
So now we did up till finding which sensors giving anomaly detection, anomaly error, for example, based on different parameters. But after that, the next step would be, we could use one of the parameter, like anomaly detection is one of the parameter for classification or the threat profiling, which is our next job actually.
Okay. Thank you.